Andy, welcome to Stories in AI. How are you today?
Doing great. It's a awesome Friday. The weather's good here in Austin. Can't complain.
It's beautiful. I know. We're just on two different sides of the same city, Austin. I'm in Austin, you're in Austin. You're in Georgetown, actually, so don't cheat.
Yeah.
But it's still kind of Austin.
I'm cool too, man. I'm still cool.
No, you're a blessed man. You lived here in downtown for a long time, right, before you moved up there.
Yeah.
And
We decided we moved to the country before it was cool, like back in, before COVID happened. So
pre-COVID,
um now
how
it's
is the
like everyone's
do?
moving up here, but yeah.
That's true. It's the coolest thing to do, and the real estate prices. I'm sure you're glad for it, right?
Oh,
Anyway, Andy, thanks so much for taking the time today. Why don't we start with your personal story? Give us your background and how you got into data science, your research interests, the whole nine yards.
yeah, that's a fun one. I've been listening to a lot of Dan Carlin on talking about podcasts, and he was always like, "Well, you got to think how far back you really want to go, right?" And like, so he'll start like the Greek story all the way with the Assyrian Empire, and you're like, "Okay, how did that work?" Um, so maybe for me, I guess I could start like in college, I was a physics and math person, and I argued a lot with people in the philosophy departments. The philosophy department had better parties than the physics people, and so I would end up there, and I ended up getting a degree in philosophy, and
Uh-huh.
from that, like, kind of fell in love with like the logical side of philosophy, and like the reading like the Carnaps and Wittgenstein, and like these people who like really went in the depths of logic and like how reasoning works and whatnot. And so you get done with your bachelor's, and you've got like a philosophy and a physics degree, and you're like, what the heck do you do now? Grad school. So I actually applied to like 8 grad school programs, one CS, one math, and then the rest were philosophy. And it turns out CS pays the best. So here I am. It was like you could come to our philosophy and pay us, or you can go to math and like do something else. But CS, like, they're like, we need you to come teach classes. We'll pay for everything. We'll give you a stipend. And so
Yep.
I ended up in a CS program. But my true love was more like physics and
Everybody,
philosophy.
yeah, everybody's history is actually a very simple logic if you think through the threads, right? It's always about having fun and making decisions that optimize for that. It's about optimizing
Right.
for money early on in your life, right? And it's
Yeah.
probably also optimizing the subjects that really gets you excited and energized. So go ahead.
Yeah,
Sorry.
and that's totally right. Like, it's we know now that humans are in the economy, and we make the
Yeah.
best choices of the ones available. And so at the time, like, CS was like the one available, and in like I ended up in a school that was a little bit weird because it's University of Chicago computer science department, and they were a very theoretical department. So any other place it would have been called a math department. And in fact,
Uh,
like, one of the guys I worked with Carnap, who was like one of the guys who worked with Girdle. Like, so like it was like in this sweet spot of like, you know, the most philosophical, like mathematical, like CS department that exists on the planet. Um, and so I think pretty recently, one of the guys who solved the quasi polynomial times algorithms, like between graph isomorphism, like, he's from there, and like I studied with that guy. So like, let's see, bye bye. And so like, so it ended up like being like this weird quirk of like, oh, there's like all this weird stuff at this one place, and it kind of came together. And I actually, one thing that really inspired me there was I was I saw what was happening in the medical field. We were talking about medicine before this started, and there was a professor, from he was, I think he was I forget where in California. It might have been Berkeley or No, I think it was
yeah.
Stanford. Um,
Sure.
I realize they're two different campuses, but to me, it's just like, it's California.
It's
Uh,
all the same. It's on the west. It's in the west.
right. One's a golf course, one's a slum. It's okay. Um, but the but yeah, this professor Charles Taylor at Stanford had done all this stuff on predicting heart failure and predicting heart attacks, and
Mhm.
he was coming at it from blood flow problem. Like, he's like, what? How does it make sense that you turn off? You don't walk into your house and turn on the the water and then like expect the lights to go out. Like, why is it that like when blood flow starts happening a little bit differently, like all of a sudden the rhythm of your heart just goes wacky, and they
Yep.
kind of like it turned into like this really cool like problem like of like, all right, blood flow, what's the actual interaction between the ion channels and the blood, da da da, and you get into like the whole thing, and it's like, all right, there's a lot of data coming into these pieces, and it's like mapping a lot of like different really cool physical systems. And well, it turns out it's really hard to do it at scale on a computer, and I just fell into that, right? And so like I became the guy that was putting math on computers, right? So like all these crazy ideas. My PhD was really about like let's just call them wild ideas about fluids, and we were trying to
Yeah.
solve some of these problems around flows in the body, and it just kind of came to, in order to do that, you had to write libraries that worked on very large sets of computers that we weren't like really processing a lot of data, but we were generating a lot of data to like to actually flow through
You
the
build
mathematical code,
infrastructure for it. Yeah.
right?
Yep.
And so then like after at the end of all that, like we had some things that like we built this project called the Phoenix Project, which was able to built. It was a compiler that I could run on like supercomputers, and we ran on like 500,000 nodes, and we're doing like really kind of crazy studies at the scale that's like beyond like what was normal, and that was a lot of fun. And so you're like, all right, how's that translate to like real world life? Well, um, I was a student. Students graduate. I graduated. I came to UT Austin and started doing some of that same stuff, and it was just like, well, there's this is great, but like the impact of like big data over here, they're doing the same techniques. And so
You-
I saw like I could start at companies and jump into that world as opposed to like wait forever to get anything through the medical world. So that
Yeah,
was
it's
it.
actually interesting you say that. So two things, two quick observations. One, I did see that you were actually when you were doing like rheonics, right? It's the flow,
Yeah.
the term that actually describes that. So I did undergrad in mechanical engineering. I don't know whether I ever told you that. So I was all into computational fluid dynamics, and
Cool.
I still remember back in the day we were like I was I grew up in India, so this was in a college down in South India. So it was actually early days was modeling with ANSYS and
Yeah.
some of the early tools that are available and writing in MATLAB, right? I mean, it was all about
Right.
just trying to actually model these things. And to the interesting observation there, and it's and I'd love to hear the after story, right? Because you realize that the infrastructure was not ready to actually handle a lot of that, right? The big data, the handling big data. And the second thing that I know you were about to go to talk about, the next you're going to tell me about TACC, the work you did there. And I just remembered that we might have actually interacted when I was at Dell, and it was my team that was actually working with you at TACC. So Jay Bosso was there, and
Yeah.
I think a bunch of different folks that I remember interacting with. So we might have
Oh
actually
yeah.
interacted back in the day.
I'm sure we met at a happy hour because there were. I mean, Dell, like that's what I really remember about Dell. Like they gave us tons of hardware and lots of happy hours because every time we published, they
Sounds about
they
right.
got another. Yeah, no, that was actually so. In that you're right. Like out of school, I ended up at the Texas Advanced Computing Center, which is like the one of the premier computing centers
Sure.
in the world, but definitely for science and open science. And so they gave me kind of a place to do the postdoc, and we pivoted a little bit from like just compilers of just these discrete CFD models to like just linear algebra in general and so forth. But that's where like I was helping scientists day in and day out actually use these massive machines to achieve their work. And I think the best was like I arrived and there was a study of this astrophysics group that they were like, our code is too slow and it's going to like take till the heat death of the universe for it to like actually do the thing we want. And and we like rewrote it and like ran it in 23 minutes and like and they're like, oh, how the heck did you do that? And you're like, well, yeah, you don't make everything an object in a list and like iterate it with an in order n squared algorithm. Like you just kind of like figure out the bottleneck and whatnot. So there I knew that like I was just that I was made for like actually helping people get problems on big computers. And like there is a difference between one of my advisors was a bioinformatics person. He's like, it's much easier to get like computer scientists to understand enough biology to get it on the computer than the biologists to understand enough of the computing. And so like there's just like this skill of like getting the math to scale in the right way. And and really just sitting on a help desk and helping tons of researchers at UT Austin and publishing papers with like the amazing groups there, like that kind of honed like a lot of the software skills and the scale that we needed and whatnot. And so yeah, so like we probably did meet, and that was the fun part of that world was like you got to see like every crazy architecture. We had a box which we called the chicken fryer. I don't know if you remember, like they probably still do this, but they have these computers in order to get them to the lowest temperature possible. They put them in like all your machinery in mineral oil, and so
Yep.
and so you have like a jet going through there, and like you walk in, it's like, oh, the chicken fryer is hot, you know, and so like you get all sorts of. We had another one that was like this crazy network system that you had to like program like the packets just landing at the right computer to do things, and so there's some interesting kind of problems. So these days when people talk about like TPUs, I'm like, yeah, that's not exotic at all. Let me tell you about like the crazy days of the 2010 and like 2000 and 2010. There was a lot of crazy architectures that were kind of being floated around before GPUs kind of came back and took over everything. So I did TACC for a little while in university, and I remember sitting in the university saying like, you know, I don't really want to like, I want to have more impact, and I don't want to like just sit at the university my whole life. And so ended up taking some work with InThought and doing some stuff on Wall Street, and like, yeah, I don't really like finance. And then Travis Oliphant mentioned he was like starting a new company and we should kind of work together. And so Travis Oliphant's the founder of NumPy and SciPy and has done a lot of stuff in the data science world. And so I was, I guess, employee number one of Anaconda, and maybe like founding team, however you want to put it. And so we kind of sat down and like, I remember going to IKEA together and getting furniture and whatnot. And we're trying to figure out how do we build the next kind of layer of the tools so that they get to the big data issue. Cause like back then it was, and this was 2011, I think you could use Python and you could use all in R and all these programming tools, but they didn't really scale. Like they hit a bottleneck at like once your data got into memory, and they didn't integrate with databases as nearly as well as they do today. And so we saw that like, you know, all right, we have all these folks out of academia that are doing big computer stuff, like on big computers like I was, and we have like the tools that like they're using, but they have to customize it all. How do we make that a lot easier to customize? And that was kind of the birth of Anaconda. I think we originally were working we'd worked together in InThought. InThought was very much like, very focused on desktop and rapid prototyping. And we're like, no, like we really wanted to go beyond the cloud and use like big data and whatnot. And so kind of out of that evolution, Peter Wang and Travis Oliphant kind of started the company, and then very early, Hugo Shi, who runs Saturn Cloud now, and I and Brian Brandevin, who built out Boca, which is one of the tools used by some of the major visualization systems. And we kind of sat down and like came up with a plan, and that's where I built out this system called Blaze, which was like basically I would just call it like if you took a database like and defragged it, like actually took it all apart and say like, all right, you still get your query engine, you still get your analytics engine, and we'll just integrate at the different layers. And it turns out that's very similar to what Tableau, the founder of I forgot his last name, but he worked with Pat Hanrahan on like a paper on how to decompose the pipeline of visualization. So we built something very similar, an engine underneath the hood. And the way we got it funded was through the DARPA's Memex systems. And so DARPA had two programs, XData and Memex. XData was like, basically what happened was Chris White, who was right out of Johns Hopkins, he went to Afghanistan and tried to use data tools and whatnot. It's like, all right, like the old ANSYS or Microsoft models, or SAS stuff, it just would break down and you couldn't fix them or whatnot. And you saw like how people like doing very basic things would be referred to like just big Excel spreadsheets, but the open source tools weren't quite ready for him. So he's like, I want to invest money to make it so that we can have better open source tools to solve these problems. And then out of that, he had like the next program, which I think was a pretty good way of like thinking about when you're doing innovation. It was like, all right, we got to build the infrastructure. It was X data, and then the next one was Memex, which was really about finding trafficking on the internet for
I remember
better
that.
worse.
I
There's
think Trina was involved in that too. I
yeah
remember that
yeah
project. I'm not
Katrina
sure.
Real worked. She actually I hired her, and it was like a fun story. I think she'll always look at me when this happens. With like I was invited to go to Apache Con, and at the same time we were like her second day she arrived, and like there's this big they're like, oh, we've got this meeting for you to present the results. I'm like, I'm a keynote at Apache Con, I can't be here. And so her second day she arrives and she's giving a presentation on some work that she didn't do to these like generals like so at DARPA, and it was
And
like so
now that's the norm for any data scientist joining in
yeah.
any organization anywhere.
In 2 days, you're going to report to the Joint Chiefs of Staff, and don't worry, it's going to go swimmingly. Don't worry. No,
That is awesome.
I think if she hadn't have been there, like this is what one of the things I always tell people is like you got to be able to communicate well as a data scientist because you never know who's going to
Yeah.
walk in that room, and getting that algorithm right, like, and she just nailed it right, and so I think that if she hadn't been there, that would have been the death knell of that project. Um, but yeah, we were, I mean, trying to find trafficking on the internet. Like I say internet because like they've been a big play of like, oh, in the dark web and the deep web and da da da. And like at the end of the day, like yeah, it's basically there was like some sort of stuff behind onion routers and behind Tor and other things. But at the end of the day, like a lot of like what was happening, you could just find people posting in bulletin boards or things like that. And so um, that was very interesting, like as an application of like our tools helping people like find missing children and find kind of real kind of problems that happen in the world, and using those tools to scale up what the analysts needed and whatnot. And so had a lot of fun doing that. It was a huge project. I got to work with NASA at NYU and kind of go through that whole PI world. It was a little bit crazy. I mean, DARPA doesn't, they always want to dial it up to 12. They don't really want to mess around. Like,
I don't-
oh, okay, you can do it. You can find some human tracking here, but let's do it for the whole world, right? Or let's do it for like 10 different variations. And so it really kind of pushed the innovation side. And so like DARPA's got a whole model of innovation and whatnot. So that kind of helped form a lot of that project. And out of that came, so we were funding the Blaze, but Blaze, like, it had a lot of problems as far as like, what it was generally trying to do is take like NumPy to all these different ecosystems like SQL and Spark and all these other kind of places. And we had like array library mappings and whatnot. And out of that, the thing that really kind of took off was DASC, which was the execution layer inside of it. So if you think about, all right, you have the query layer, and like that was all NumPy type syntax, and then it would get translated to something that would then take it to the different backends. And then it would be, and Dask became our execution layer. I mean, at the same time, like Apache Arrow, which is getting a lot of press right now, was doing a very like they kind of Wes McKinney kind of took the same ideas except applied it just like let's just work on the memory side of it, not just work on the actual execution layer. And so like you kind of see these two like I would call them like up and coming platforms right now where like Spark had already like Spark existed and they were actually there with us, but we kind of ended up developing similar systems and Arrow wasn't a part of that initiative, but we had a different one that was very similar to Arrow. We called it Thunderdome, and we were able to run like a 40 terabyte graph on it at one point. But because it's the internet and like and DARPA, let's just download the whole thing. You're like, okay, let's try. And so so out of that you get like these tools they're not the same as like a BI tool, but they're like a lot more usable by data scientists. And so that's kind of like how my career kind of took off, is just helping building tools for scientists and data scientists. And so that's kind of the gist of that. And then after that, I was, I've been a big part of NumFOCUS, which has been there to like help fund these tools, and that's where like they fund like 100 projects now, but like big ones like Jupyter, Python, or Pandas,
Yep.
SciPy,
Coverage.
some of PyTorch stuff. I mean, there's like quite a number of things, and at that point, it was just all right. All these people are building these tools. How do you like make sure that they have a sustainable community so that they can
Yep.
support scientists? So
Yeah, no, I think the work you did, and I met a few other folks too at NumFOCUS was really awesome, right? And this was the days where those tools and infrastructure capabilities were really needed, like for data scientists to do their work. So pretty amazing. And a few other things that came out of the background you were talking about is one is the notion of as a data scientist you need to be able to communicate very well,
yeah,
right? You talked about data visualization. I want to go double click on that a little bit more. And then the whole notion of innovation starts with, you're trying to solve fundamentally, you start at the infrastructure layer, it's trying to solve, okay, here's a big audacious goal. How do we solve it? What do we have? What do we not have? And then start building out, like layering up the stack needed to go make that happen, right? I think it's very fascinating. It's very different, right? I mean, than most when startups think about let me go solve a new problem. um, some people call this the first principle thinking, right? The whole idea is like, what do I have, what do I not have, how do I layer down the stack and start from the bottom and then build it back up, right? What would the
right.
most optimal, most ideal solution look like? So it's a lot of nuggets in there in that background. So bring me to today and talk to me about AI and all the ML work that's happening. I mean, in your world and outside, right? What is your 50,000 foot view of where AI is today in the market?
Yeah, you know that's a great question because I think that it's really we're at a moment right where like AI needs a little bit more definition than what it's getting in the market. And I mean, like, so I was reading the data science today, right? Like a lot of what they do is like what we used to call data analyst, and data analysts are
Yeah.
doing a lot of what we called, database administration and things like that. And so, like even the word AI, like you get like was it Michael I Jordan who was saying like don't even call it AI, call it like statistical engineering, and so like there's this huge back and forth and like all right yes in the world of AI, there's definitely algorithms and automated ways of thinking that allow you to build systems, right? And so whenever I hear the word AI, I'm usually like, well, you really have to have a whole system to be an AI system piece. Like you can't, learning isn't like enough. You actually have to have control and integration into your whatever feedback loops or whatever it is that you're working with. And so I work at a lot of companies and actually build myself as an AI executive because like it's like well who knows what AI is, so like you even call themselves an AI executive I guess. But to me it's about the system of using automated algorithmic learnings and also all the feedback loops to make that happen. Like today, I work at Xometry, which is a cloud manufacturing system, and so we use a lot of AI. We're definitely an AI system, and there's a lot of data scientists working on things like our marketing systems, working on like business operations. But the heart of like
Yeah.
what we do is just like pricing algorithms and like picking who should build parts. And so like in cloud manufacturing, you upload your part file, and instead of like going to your local shop, like we analyze it and then say, all right, we have 5,000 people who could possibly, or 5,000 manufacturing shops who could possibly make this part, and then we match them up. So then it takes away the the problem of like if you need a part made, you have to go to like 10 people get quotes, and like you don't even know who's going to make it, and so forth.
Yeah.
Um, and so we can solve some of that. So like, as an automated system, like all right, we can provide better information because we're seeing the parts from all these 5,000 partners come through us. We see your part, we see who's going to make it the best, and we can both like optimize your price, your lead time, and many different pieces to it. But that's just just the analyzing and the algorithm of the machine learning to like figure those pieces. That's just one piece. If it goes to that a manufacturing shop and they don't do a good job, well, we have backup systems and fail safes to
Sure.
fix that sort of thing, right? And so it's just like if you're going to build a car, like you can't just build just the thing that tells you how fast to go. You have to build like all the things that like, we screwed up, we got to back up, or we got to reroute and things like that. And so to me, when we talk about AI, like I think that's where the industry, like there's the marketing speak, which is like, oh yeah, anytime you have like a linear regression in a spreadsheet, that's AI. And like, okay, great, you guys go have fun. But like when I think of AI, I really think about these like systems that, you know, are adding automation to them. And like I always tell, I give this book to all my teams whenever I started, like the goal by Elihu Goldratt. And like, I mean, it's a, you know, business 101 book, but like you go and you're like, what are the problems they were trying to solve in that book? It was like they were bringing automation and robots to factories in the 80s, and like they would add a robot, and it didn't make them faster, it didn't make them better because they didn't fix their processes. And
Yeah.
it's a book, like it's a fable talking about how do
Robot
you think through like the actual goal of your business. And I think
Yep.
a lot of companies need to do the same thing with AI. Is like, all right, so I have an automated system. It can take, pardon, but another kind of metaphor to this I give to folks is like, if you're making a decision on Excel spreadsheets, how often are you going to be able to make a decision? Maybe once a week. You're going to have errors, you have check, like you're going to get things going on. You move it up to a database. Maybe you can do a daily sort of thing. You get to a real-time system, and now I can actually have updates and live feeds, and that's you in the big data world. And then you can start to like think about automating these pieces. So if, there's no point in automating a decision that's going to be made every week, but if I can automate something that's going to be made every 2 seconds, like that's like now I can
That's
invest in machinery. And the same thing with like robotics in the 80s. Like, all right, so I have a thing that can make more parts. Well, what did it do? It just made it so like, all right, well, the bottleneck ended up being like the heat treat plant, or getting materials to that robot or something. And so AI, I think, is, as an industry, it is in that moment where, one, we have to shed off like all the kind of hype stuff around. It's just like, I'm sorry guys, like data analysts, I
Yep.
love you, I think you're very valuable, but please stop calling that AI. Just because you're doing linear regression, great. I mean, linear regression can work in an AI system. That's not the issue.
Yeah.
But it's more that, like, as a business, you really need to have the whole processes around that. And I think that in the news, I was at a startup in real estate, as you know, at Rex Homes. And in the news, I mean, we ran a lot of pricing algorithms. And in the
Yep.
news, you see Zillow famously pulled out of all of its algorithmic pricing and its investment buying. And like, yeah, you dig a little deeper in what happened, and I look at it as like, yeah, there was the system layers that didn't exist, and when they spent too much money and were overcapitalized in this market they couldn't predict, they didn't have those fail safes. They failed at. They had the AI, like just the learning algorithm told them what to buy, but they didn't have the systems that fed them back actual
Oh,
data and portfolio management and whatnot. And so, like, I look at that underlying. That's probably the biggest thing that failed at that company. And AI, if you don't build it as a full system and your
yep.
entire company, it's going to have a lot of challenges.
No, you know, when people, and I completely agree. I mean, people ask me, like, you know, what's the difference between AI and ML? Isn't that the same thing? I'm like, look, one is a technique, one is an approach, right, at the broadest
Right.
sense. And to your point, like AI should be truly, you know, trying to get to artificially intelligent systems where you're trying to get cognitive functions on a non-living thing. You have to think about it as a system, not just the fact that it's going to run a regression and give you an output or a score, right? So you have to start thinking about how is that being used. So building an AI system, and this is like my question to you is like state of the enterprise today, right? A lot of ML building happening, not enough AI
Right.
system building happening, right? I mean,
Yeah, yeah.
uh,
And I think product managers, like you see, like maybe the last 2 decades have been like the era of the product manager. And like a product manager who doesn't understand how AI algorithms work is going to have a hard time in the next 20 years, right? It's because it's becoming like just table stakes at this point. Like everybody
yep.
is running ML and they're hiring machine learning engineering, but it doesn't work the same. It's not like building a web app where like, oh, I told the engineer to make this the pixel perfect thing and it was made and then we monitor it. No, no, no. Like it's a probabilistic system and you've got to have a little bit more give and do analysis around the actual states that it can get into, and then and the backstops there. And so, yeah, I think that AI, you can still be an AI and not necessarily be the machine learning person or the coder or something else, but like you still, as a business person, need to understand how these algorithms work, because if you don't, you're going to be really surprised by the effects they have, like the Zillow case. And if you don't like help learn it, like
Consequences.
it, I mean, I think AI is eating the world, and like yeah, I think at the end of the day, it's a better way of making decisions because you can act so much quicker on the data you have. So
No, I makes total sense. No, I think it's it's interesting, and you have had a lot of experience across multiple industries. Not just It's not limited to one industry and stuff, which is what I love about your background, right? Because you totally have seen this, and in different industries are at different stages of maturity in applying these
yeah,
techniques, right? So what financial
absolutely.
services does, real estate is very different, and bringing that system level thinking, bringing that whole. I love what you said about product managers because one of the things that most organizations have struggled with, they start their ML journey or AI journey by hiring a bunch of data scientists, and then they realize that these people start complaining, so they will go and hire a bunch of data engineers to help query data and give it to them, right? And then they're still like, why am I actually not going into production? Because you haven't really
Yeah.
defined a function of taking technology and putting it to use, and that it's been the era of product management, as you said, right? It is, I would say, the one of the biggest gaps I've seen in most organizations is actual and redesigning your product management function to work with evolving systems like machine learning algorithm based products, right? So it's an interesting thing. Let me ask you a question on the data science side itself, right?
Yep.
What makes a good data scientist? I mean, how do you what are the characteristics you look for when you hire people? And then what's your advice to people trying to become good data scientists?
Yeah, and I'm a big tent kind of person. I just I've had data science teams and like so and I've helped build lots of like in this I'm advising like 6 companies now and like and I help them try to think through like what kind of data science team they want. And there's groups that are very much like goal oriented finance type things, right? Like I need to like I have maybe just the way I'm doing some pricing or the way I'm doing some optimization of a process. And then you have like very engineering organizations, which is like, I need to automate at scale or something. And I always tell people, there's basically 2 tricks. You can analyze things much better and much more automated and like give a real deep causal analysis, or you can automate things. And like when you can do both, it's awesome, right? But to be honest, like you really only have 2 tricks to analyze and automate. And as somebody who's getting into AI, you kind of have to figure out what your passion is, right? Because if you love
Mhm.
finding that nugget of truth, it's like this is like the aha moment. Then you're the analyst side, and you've got to really learn how to communicate. You've got to learn how to um, model the domain that
Interesting.
people are at, like work with subject matter experts to like take the things that they're in their head to like actual like data and like represent those in algorithms and whatnot. And then you got to know your statistics and all the different pieces of that. If you're like, well, man, the really cool part is like making this work for 10,000 people at a time, or making the car drive itself. Like, all right, great. So that's more the engineering, the automation work. And so now you got to really learn how to code. You got to learn the DevOps world, and you have to kind of understand like what this like. Oh, I have an algorithm. How do I get the feedback loop in that algorithm? How do I make sure the data's clean and that sort of thing? And so like once you've kind of established those 2 things, right, then you can kind of like piece together like what your career might look like, and like both like amazing opportunities at them. And so and now you see in the market a lot of times we like call the automation like ML engineering, and data scientists kind of become like the group that's doing a lot of the analysis. Even to the point where some folks like, yeah, if you want to be a data scientist, you got to know SQL, like and I mean, I'll admit I didn't learn SQL until like way late in my career because like I was more the automation guy, and I've had cases where like one of the best data scientists I worked with, it's a kid from Berkeley, and like I gave him once one of the analyzed problems, and like he totally failed. He was like, I don't know how
Because he
all this
couldn't.
data works together or whatnot, but I asked him to build me an algorithm that like tells me like the square footage of any kind of room given like a few pictures, and like he could do that very accurately. So the split is pretty real. When I look for teams though, I look at like, all right, what are the goals of the organization? Like, do they need help like just translating the business problem to like data problems? Do they need help actually just automating those problems? And so I looked for those pieces. Like, and if you try to fit a data scientist in any one of these holes, that's where I see a lot of failure, because you can't just put somebody who's like really good at automating and like expect them to go find the fault in your maybe your marketing strategy or something. And so in that, like helping people kind of learn those pieces. So if you are in that analyzing side of it though, like then it's like the analyst folks, really communication matters so much just because you have to work with your stakeholders and to
Mm.
translate what they're doing. And there's been a lot of like nuance that comes out. Like a good one, for example, when I was doing real estate stuff, like real estate has a lot of weird rules in it. Like for example, here in the U.S., if it goes live on the market, you start calculating what's called the DOM or days on market, and that thing like can be reset in various ways. And you're like, well, that's interesting. As a data person, like I see it's one day on market, but it's like, well, there's a true day on market, and like people who bought houses here kind of know this, like, huh, that house was on the market, but then it went off, and then I came back, and so it might say 2 days, but it's actually been there 6 months, right? And so like that little nuance, like if you're not listening to your subject matter experts to communicate with them, you're going to miss it and just totally blow the modeling. So that,
Yep.
I mean, those are a few guidelines there.
Got it. Yeah, no, in that case, in that scenario, right? Imagine having all the weightage like on that particular thing, and then suddenly you're just
Right.
looking at dud houses that has been in the market for a long time and then pulled out and then put back in, right? So,
And I'll tell you, like if when you run your first linear regression algorithm on housing prices, like DOM is a huge one because like it's one of the only things that can tell you that this home probably has something wrong with it. Because if your DOM goes too high, like if it's outside your standard deviation of your market, like usually that's an indication that there's something wrong in this house that's being hidden. And so
that's awesome. No, I think this is great, Andy. I mean, a lot of practical nuggets to pull out of here. Let me, and I know in the interest of time, I want to try to wrap up. Give us if you're an organization, what's your advice to organizations looking at AI, either starting their journey or if they're already in the journey, how do they scale it? Give me your top 3 to 5 pieces of advice.
yeah, I mean, the big one is to invest in teams and let the teams like figure out organically like who they need, right? Like you said, like a lot of folks are like, oh, we'll hire 10 data scientists. Well, hire one data scientist and one engineer and one product manager and like let them organically figure out what problems they can solve together. And then it becomes a little bit more pressure on like get the right ones. But so maybe you
Yeah.
hire a couple of teams, but like really bring them together to teams because I have a strong feeling that if you put data scientists in just off on their own, like that doesn't really work nearly as well as like embedding them with teams that are trying to solve problems. And then like you can kind of like start to find commonalities and bring that together and have some more centralization. The other side is like, yeah, your data matters probably more than you ever know, right? You need to very, very much like care about your data model. If there's anything I would say to every CEO out there that thinks they're an AI company, if you can't tell me how your data model works, you're not an AI company. Period. Like in AI, data is like it's fundamental, and like companies kind of like shovel that off and like that's the data engineering team's problem. Like no, I mean your core business has to be really brought down to some like very fundamental objects and like data interactions that you can understand. And so those are two pieces of advice. Make your teams diverse and give them like kind of like all parts of the problem and like make focus on your data a lot.
That is that is so awesome. You know what? I want to actually bring you back on the pod like later on a part 2
Yeah,
discussion where I want to actually explore a lot of the industry use cases that you've actually done, like more in the world of applied AI, right? But thanks for
right.
sharing your insight. How can the viewers and listeners get in touch with you? Where can they find you on the internet?
Well, if you try to touch me on LinkedIn, I'm around. You might be like filtered out from all the like the you have to be somewhat these days like all the recruiters and all the like sales vendors like
Just
hit
call
me up
out that I
there. But
heard your podcast. I
yeah,
heard you on Stories in AI, and then there
yeah,
you go. You get the right
just
approach,
mention
right?
Ganesh's name and like we're having beers together. That's enough, right?
So I love that. I love that. That's awesome. So LinkedIn, and I'll put that in the show notes as well. Andy, thank you so much for taking the time. It's always a pleasure. I learn so much every time I have this conversation, any of these conversations with you. Next time, we're definitely doing it over a beverage. And then until then, thanks so much for jumping on.
Right. Take care. Thanks, Ganesh.